Good afternoon. My name is Charles Beumier. I'm working at the SciLab of the SIS department of the Royal Military Academy. The present talk is about penetration testing of a 5G application. The plan of the presentation consists of 4 parts. First, presentation of the project 5G Orange BE, then of the application team on mission, the pen testing of this application, and finally the conclusions. The project 5G Orange BE occupied the following partners: the Belgium MOD, the Orange Belgium Company, and the Streamwide Company. It was funded by the SPF Economy in the years 2023-2024. Its objective was to test 5G as a telecommunications solution for the Belgium MOD. The security aspects had to be analyzed for the radio and application side. It was also seen as a potential future replacement for TETRA. TETRA is a digital radio for secure communication. It is used by military, police, and emergency services. The role for the RMA was first to test the radio security. This was done by the radio network unit of the SIS department, and also to test application security by the SciLab. The SciLab role in the project is to test mission-critical push-to-talk application over a 5G and to perform the pen testing of the team on mission application. In the figure, you can see a Crosscall Z5 handset connected to the 5G network, and on the other side, the server for team on mission. There are several risks, as for instance, the possibility for an attacker to access the application, to extract the keys for connection, or to steal or clone a SIM card, or to sniff the packets of the connections. 5G is well adapted for a push-to-talk application thanks to the ultra-low latency from the near-instance voice transmission, thanks to the guaranteed quality of service, supported by the network slicing, which can prioritize critical traffic, thanks to seamless mobility from the fast handover with no voice drop, and enhanced security from the strong encryption and secure network design. The application team on mission was developed by the Streamwide Company. The aim was to provide forces with an innovative, secure, and sovereign solution to optimize operations, to improve security and crisis management, to strengthen team coordination in real time. It is used daily by more than 500,000 end users. It was, for instance, the primary communication solution during the Olympic Games in Paris. The team on mission features are: it's a push-to-talk application over 4G and 5G for group or individuals. It supports multimedia messaging like text, images, files, voice. It has video and voice calls. It has geolocation and tracking. It provides emergency alerting, like for instance when a man is fallen down. And it has encryption. The main topic of this presentation is pen testing. But what is pen testing? It is penetration testing, that is the simulation of cyber attacks to identify vulnerabilities. The key goals are to mimic real attacks, to assess risks, and improve security. The Cyber Command helped us with technical support thanks to its experienced personnel and special equipment. 5 different actions were undertaken to pen test the team on mission application. First, a static analysis of the Android package kit. The objective is to search for weaknesses in code or libraries with specific tools. Tests were performed with an old version. Some vulnerabilities were found, but this is due to old libraries not contained in the current version. But it was too late to test the current version. This is a topic for future work. This shows the importance of regular software update. Streamwide provides minimum 2 updates a year. The second test considered network scanning in order to identify open ports. For this, Picadrate was used to identify IP addresses and then Nmap. Open ports were discovered, but no one appeared suspicious. Then vulnerability scan was performed with specific tools to identify and report security vulnerabilities. No vulnerabilities were found, but we have to say that default settings of the tools were used. Next, the smartphone was tested concerning its usage, acquisition, and access. First, the documented stream-wide security measures was tested. For instance, this stipulates that it's not possible to launch the application if there is no screen lock, or that it's not possible to take screenshots. These security points were not active, and the reason is that we received a non-production package. Due to lack of time, only the default configuration was tested, although additional security options can be enabled. This means future work. Secondly, the phone was tested to see if it's possible to acquire device data. It was possible, with or without screen lock. And here again, the reason is that we received a non-production package. But the main question is, are the messages accessible? This needs future work. But we can already say that the current release implements full encryption of mobile data at rest, so that the messages, even if accessible, won't be readable. Continuing with the smartphone test, key access was tried. This is possible from the Android key store or by traffic sniffing. The conclusion was that the connection key could not be found, so there is no risk for the keys to be reused for an illicit connection. Finally, network capture was intended. The idea is to record packets to be analyzed possibly later. The connection traffic could be captured, but it is encrypted. However, there is a long-term risk due to the quantum computing, which could possibly, in the future, decrypt what is nowadays considered as safe. But the team on mission server is using Red Hat 9, and it will continue to use Red Hat, and Red Hat is preparing encryption with quantum resilience. The team on mission application can be used from mobiles, but also from a desktop with a web connection. The last point for pen testing considered the web application, where the objective is to simulate attacks against the web server and its application with specific tools. It was possible to scan files and also to find software versions, and it appeared that the tools are up to date. There is no exploit known related to those tools, so that we are on the safe side. As far as the conclusions are concerned, we would like first to thank the Cyber Command for its technical support. We presented pen testing of the team on mission application. Several scenarios were defined with corresponding attack vectors. Tests revealed vulnerabilities, but all seemed to be addressed. It was more a question of versions or configuration. This highlights the importance of using updated versions of software. There were limitations, like the lack of time or skilled personnel or specialized equipment. And this means possible future pen testing work, like for instance, repeating tests concerning sections A and D of the presentation, or exploring other OZ layers because only the 7th layer, application layer, was considered in this work. This ends my presentation. I thank you for your attention.